Today we're going to be talking about series and parallel circuits in AC, otherwise known as alternating current. To know what series and parallel circuits are in AC, we first have to get familiar with DC and AC current. DC current is direct current and remains constant, whereas AC current changes with respect to time. Solving AC circuit problems are exactly the same as solving DC circuit problems, with the only difference being switching the algebra to complex number algebra. There are three important elements for these circuits: the resistor, the inductor, and the capacitor. Resistors are the real part of the equations, and the inductors and capacitors are the complex parts. When solving these problems, inductors are added and capacitors are subtracted, and we use reactance as a measurement. So here, since we have alternating current, we use vectors and not scalars. R represents the magnitude and the theta represents direction. This is the polar form, which means it can also be written in rectangular form. Using the two equations listed below, you can convert from polar form to rectangular form or vice versa, depending on what suits. Usually, polar form is better for multiplication and division of impedance, and rectangular form is better suited for addition and subtraction. Calculating inductive and capacitive reactance is as simple as following these two formulas at the bottom of the screen. As we can see, the reactance depends on the frequency. When dealing with series circuits, calculating the total impedance is as simple as taking the real and complex components and adding them together. Here, we can see that the total impedance is equal to 7 plus J4 ohms. This is in the rectangular form, and this in polar form is expressed as 8.06 ohms at an angle of 29.7 degrees. On the right, we can see the process of how the polar form is found. On the other hand, parallel circuits use the same process as DC circuits as well. Following the formulas and solving the complex algebra, we get a total impedance of 1.96 ohms at an angle of 11.31 degrees. At the start, we can see that we keep it in polar form for the division, and it is then converted to rectangular form when using the addition to add them together. And then it is then converted back to polar form. This sums up how series and parallel circuits behave when alternating current is used, and a step-by-step process of how to solve AC series and parallel circuit problems. Thank you.